Okay, so again, we were left cut off right here. So we're finding the degrees of freedom, which should be 3 columns, take away 1, times 3 rows, take away 1. So that's 2 times 2, which is 4. So there's your degrees of freedom right there. And then we're going to use that to help us with our critical values. So step 4, we're going to need a critical value. So that's equal to, and this is a chi-square distribution, so you're going to want, oopsie, hold on. I was just trying to bring that over. Okay, there we go. So equals chi sq dot inv dot rt. Again, these ones are always right-tailed because you skewed everything, excuse me, you squared everything, and when you squared it, you turned it all positive. And the probability is going to be alpha, which is 0.05, comma, degrees of freedom, which is 4. Let me double check that with my table. Yeah, there it is. Alpha is alpha is the area in the right tail, degrees of freedom. Okay, so our critical value right here is 9.48. So are we going to reject? Oh, yes, we are going to reject, because we reject the null hypothesis because our test statistic, which is equal to 73.325, or excuse me, 352, is greater than the critical value, which is equal to 9.48. All right, that's the classical method. What about the p-value method? So if you do the p-value method, you want equals, all right, chi sq dot dist dot rt, because this is right-tailed. You tell it 73 point whatever, comma, degrees of freedom is 4. There we go. Oh, I forgot to mention, if you want to do this with the other Excel, it'd be equal to chi inverse. This one was 0.05, comma 4 for the critical value. And for the p-value, it'd be equal to chi dist 73, comma 4. Again, with right-tailed tests, it's just as easy one way or the other. It's the left-tailed tests that are much more difficult with the old functions. Okay, so we would say reject h naught because p is essentially 0, right? It's 0.00014 zeros and then a 4 is less than alpha, which was equal to 0.05. Okay, so there is enough evidence to support the claim. So that's what we would say back here. Oops, let me type all that up, what I just typed in Excel. There we go. So that's all typed up. So I've got my p-value here, which is really, really small, so I reject the null hypothesis. So my step 6 would be there is enough evidence to support the claim that income and happiness are not independent, despite what people say about money not being able to buy you happiness. Okay, so how will we do it with StatCrunch? Good question. Hold on, let me bring it up. Okay, so I put the observed values right here by row and by column, right? So I didn't bother putting the totals in, don't do that. But I put in what was observed in real life from this data, happiness and income. Right, oops, but not the totals. Okay. So once I put those into StatCrunch, let me bring up StatCrunch again. All right, then I go to Stat, go to Tables. This is a contingency table. You're not working from data, you're working from a summary here, right? So it's not like you had to see all 21 different people listed as, this, that, and the other. So, for example, above average and all that. Now your row labels are in income right there. So that's your row labels. So next, and it's going to say, what do you want it to display? How about we display the expected values? We would like that. And we want it to run the chi-square test. Now, if you wanted these other things, you can do that. Then click calculate. And look right there at the bottom. The p-value is lower than 0.01. The test statistic is 73. And it gives you the expected values that we came up with earlier. Much simpler than Excel, quite frankly.